Good morning, mathletes. So we are looking at more confidence intervals, but this time when we're looking at two different populations. All right, we're comparing two different populations. So let me bring this up. So again, when you're in your statistics class, make sure you understand what they're asking for, uh, understand the process and what that process tells you. And that's where you always start. Don't move on until you have a really good idea of what is it that I'm looking for. Or else what you're going to do is you're going to end up just following these steps that someone gave you and not really knowing what the heck you're doing. All right. So what I've done is I have my friends over at ChatGPT kind of help us take a look at, what is it that we're finding. So let me share my screen with you. And let's see, I think we are, nope, give me a second. Give me un segundo. All right. And then I was on ChatGPT and I was messing with this to help with people's understanding. So check this out. So in stats, we use a two sample t-test. That's what we're going to be using today. Uh, and calculate a confidence interval for the difference between two groups. All right, we're essentially trying to understand how two groups compare on a certain measurement. And we're doing this with a certain level of confidence. So let's look at the breakdown. All right, so let's understand the basics here. So you have two groups. These could be anything you want to measure. So let's say you're looking at the difference between test scores of two classes. So it could be like my online class versus my in-person class. It could be the heights of people from two different cities, or it could be the batteries of two brands of smartphones. So again, you can compare two groups of things here. The difference, you're interested in whether there's a significant difference between, say, the average mean, right, which is the mean values of the two groups. For example, do smartphones from brand A last longer than those from brand B on average? So that might be one of the things that we're interested in. Are the grades better from my online class versus my in-person class, or vice versa, right? And so we're going to talk about the t-test a little later, because right now I want to focus today's lesson is on focusing on the confidence interval for the difference. That's what we're going to look at. All right. The confidence interval, which we'll say CI, this abbreviate CI, this is the range of values derived from sample data that is believed to cover the true difference. So they're going to give you they're going to say the true difference between these two groups of the population is going to be from this number to this number. So we're going to be confident, a certain level confident, right? Maybe 95% confident that if we were to run this procedure 100 times, this interval that we get, right? 95 of those 100 times, the true difference between the two groups' means in the population is going to fall right between those two numbers, somewhere between those two numbers, right? So what it does is it gives us a true estimate of where the true difference lies. So confidence level, often set at 95%, right? But we're going to look at different confidence levels. The confidence level means that you're 95% certain that the interval contains the true difference between the group means. All right. It doesn't mean the true difference will definitely be within this range, but it's very likely. All right. So remember what is being given to you. What's going to be given to us by our calculators, or if you're doing this by hand using the formula, is a range. So you're going to get two numbers, right? Not a single number. So instead of saying the difference is exactly X, you would say we're 95% confident that the true difference between, we'll say A and B, and then is what we get. So this acknowledges the uncertainty inherent in working with samples. All right. And so let's see, it says direction and magnitude. So the CI can tell you not only if one group is highly likely higher or lower than the other, but it gives you an estimate of how much higher or lower. And decision making. The confidence interval for the difference includes 0. So if the confidence interval for the difference includes 0, we're going to see that it suggests that there might not be a significant difference between the groups, since 0 difference means they're the same. So if the interval is entirely above or below 0, it'll tell us that there's a significant difference. All right, so let's go ahead and let's do some examples so you could kind of see what all this is saying. All right, so let's jump in here. So you got body mass index. So in a survey of adults with diabetes, the average body mass index in a sample of 1,922 women was 30.90 with a standard deviation of 0.3. And remember, the standard deviation is coming from the sample. Then you have the BMI of a sample of men. So we took over 1,500 men, and their body mass index was 30.20 with the standard deviation of 0.6. All right, so they gave us these two groups. So notice, what are the two groups? Well, we have men and women. So make sure that you organize your data appropriately. Usually I like to make like a column, and I'll say, this is the men, this is the women. But make sure you read the problem. In this case, they're giving you very specific instructions, right? Because I could call group A men, group B women. But in this case, let's read. Construct a 90% confidence interval for the difference in the BMI between women and men with diabetes. All right. Let mu1 denote the BMI for women. So they're telling us that group 1, that very first group we're going to work with, we're going to call that, we're going to use the information from the women with diabetes. And we're going to use a TI-84 calculator to do this. All right. So let's go ahead and construct this 90% confidence interval. So here's what you're going to do. And then I'll do it right now. I'll pull up my calculator so we could do this together. Close this. We were working on some projects earlier. All right. So my calculator is going to look a little different than yours because this is the free version app on the Mac and on iPhones. So this is Calculate 84, which is very similar. All right. So first, let's organize our data. All right. So notice right here, you have X bar sub 1, S sub 1, and sub 1. So what does this relate to? This is the women's information. So notice all we did is nice and neat, organize all the information. So the women's mean of the BMI was 30.9. The sample standard deviation was 0.3 that they told us. And then what was the group size? 1922, right? That's how many women were sampled. When it says sub 2, right, that this represents our men. So maybe I'll write down this is our men. So again, make sure you have all this data and know what it represents, because we're gonna have to tell a story at the very end. Like, okay, so we're gonna go to our calculators and we're gonna go to test. We're gonna go to over to test, or we hit stat, excuse me, go over to test, and we're gonna scroll down and we're gonna go to to sample. There's Z interval and T interval. We're gonna go to T interval. All right, notice they give us the sample standard deviation. All right, you can either use data or stats. Here, we're gonna use stats because they provide us with the statistics. All right, so let's plug things in. So our X bar sub 1 was 30.9. S sub X was 0.3. Our sample size of the women was 1922. X sub 2, the second right here, was 30.2. I hope you guys can see that. My calculator work. I think you can. Let me just make sure that it's sharing the entire screen. Yes. I just want to make sure I'm sharing my entire screen. Then we have second sample size of 0.6. And then N sub 2, which is 1553. 1553. And our confidence level here, we are 90%. And we're always going to say no to pooled. And we'll talk about that in class. We don't have, for over 99% of the time, our population standard deviation um, is not going to be equal between the two populations. And so that's what pooled is talking about. So we'll just say no. That's saying we don't know our population standard deviation, but right, we're pretty certain that they're never going to be the same. All right, so we'll hit calculate. All right, and what it gives us is it gives us the lower and the upper range, right? So what this tells us is that we are 90% confident that the difference in what? What the difference in what? Well, we are looking at the mean difference in BMIs between women and men with diabetes, right? So we're 90% confident that the difference in mean BMI between women and men with diabetes is between this answer we just got, 0.67 and 0.73. So notice 0 does not fall within here. We'll talk about that right now. So we rounded the decimals. It's just telling us to 2 decimal places. All right. And so now let's go to part B. Does a confidence interval contradict the claim that the mean BMI is the same for both men and women with diabetes? So remember, if the claim is that the mean BMI is the same, what that would tell us is that there is no difference. And so what you would be looking for is for the number 0 to fall within your range here. And I'm looking at, this is our range, 0.67 and 0.73. Notice 0 does not fall inside here. So what that tells us is that we do have a contradiction, right? That means that they're not the same, because if they were the same, this interval that we found in our calculator would contain the number 0. And if I had 0, remember that would say there is no difference between the two BMIs for the two groups. All right. So that's how we're going to run this using our TI calculator. Let's do another one. All right. To get practice. But again, what's going to be key is your organization. As you read all this, is labeling everything. X sub 1, S sub 1, N sub 1. And then tell yourself, what does that mean? That represents the information for the women, X sub 2, S sub 2, N sub 2. That represents the information for the men. All right, so let's look at another one. Let's see if I could do this. Let me pause this recording so I can load up the next one. And while I do that, make sure you like this video and subscribe. Again, we're trying to help out as many math teachers as possible, and that's going to do us a big help right there. All right, so I want to finish with this one because now they give us some data, as we could quickly see. All right, they give us a list of values. So in agriculture, an agricultural experiment, the effects of 2 fertilizers on production of oranges were measured. All right, so you have fertilizer A, fertilizer B. 13 randomly selected plots of land were treated with fertilizer A, and 10 randomly selected plots were treated with fertilizer B. So notice the sample sizes can be different. The number of pounds of harvested fruit was measured from each plot, and here's the results. All right, so each of these numbers represent pounds of fruit, in this case oranges. All right, and they're measured. And so what we're going to do is we're going to put one of these in list 1, one of these in list 2. But as we read the questions, make sure you read them carefully so you know which one to put, say, in list 1, list 2. It really doesn't matter which list, as long as you, when you're using the calculator function, you put things in their appropriate place. So I'll talk about that right now. All right, so we want to make some checks first. So if we created a box plot of each one of these, we would get box plots that look like this right here. And we want to make sure we look at these box plots because these sample sizes, they're less than 30. So we want to see, is this data approximately normal, right? And so looking at our box plot, we don't see any outliers, so perfect. It's looking pretty symmetrical, right, with no outliers. So we could say the populations are approximately normal. So that allows us to go ahead and proceed with constructing, here it is, a 95% confidence interval for the difference between the mean yields for the two types of fertilizer. So what's going to be the main difference in means, like in terms of the average weights? Because I want to say, should I use fertilizer A or should I use fertilizer B? Or maybe do I just want to see, is there a big difference because is it worth it too? Because maybe the price difference, right? So a lot of questions I could answer here. So let mu1, so notice they say mu1 denote the mean for fertilizer A. All right. So for me, what I would do is, since they said mu1 represents the mean yield for fertilizer A, I would take this list, and just for me personally, I'm going to put this in L1, and then fertilizer B, these data points I'll put in L2. So I'll just go to stat, my calculator, edit, and then in L1, I'll just enter all these numbers. And then I'll go over to L2. Notice I have some numbers here already. So I'll go to the top and hit clear, if in case you forgot how to do that. And then enter. And then I'll plug in all these numbers one at a time into L2. All right. And what's nice is now that we have our data points, right? Our data, and you have them listed in L1 and L2. Now I could go in. All right, let me go home. I'm going to go to stat. I'll go over to test. Once again, I'm going to go to a 2-sample T interval because we do not have the population standard deviations. But here, instead of using stats, I'm going to hit data, and it disappeared. Let me bring my calculator up one more time. So stat, let me do that one more time for the East Coast. Go down. Yes, I know there's an error. That's what happens when you use free stuff. 2-sample T, use data, my list 1, I'm going to put L1, L2. So now let's say we reverse these. All right. If we reverse these, what you're going to end up with is negative answers. These would just be negative, and the reason why is because in our calculations, for those of you who have seen how to do this by hand, you'd be subtracting a bigger number from a smaller number, right? And that's why you would get such values. So here you enter things like this. You make sure to put your confidence interval 0.95, make sure you hit no, and then calculate it, right? So when we do that, notice there's our sample interval right here. So the mean difference in weight in pounds between the two using the two fertilizers is 43 pounds to 95 pound difference, right? So we say we're 95% confident that the mean difference between the mean yields, right? This is how much is produced from the two types of fertilizer is between 43.3 and 95.8 pounds. All right. In this case, they don't ask us in terms of, is there a difference? They're not asking that question. And if they were to see, were the mean yields about the same, then what you would be looking for if they're asking you that is, does 0 fall between these numbers? So what that would tell you is one of them would be negative, one would be positive, right? All right, mathletes, I hope that helps out for my class. This is section 10.1. And if you're not in my class, again, we're looking at confidence intervals for two groups here. All right, mathletes, hope you're having a wonderful day. I'll talk to you soon. Peace.